this is my PC. And it started as an innocent little Acer pre-built. But now, it's a full-blown Frankenstein monster stuffed into a Corsair 9000D. Yes, the absolute unit of PC cases. But today, we are going to be fixing everything that is wrong with it. You're probably asking, what's the problem exactly? Well, now unlike its younger, less ambitious siblings, this system boasts a Intel Core i7-13700F, a 16-core, 24-thread processor that absolutely rips in gaming and productivity. But because this thing started as an Acer pre-built, it has, you guessed it, a proprietary motherboard. This means I can't use the front I/O of the Corsair 9000D. The airflow is overkill, just like I like it. Cable management is, well, questionable. And the upgraded paths are limited. It's like putting a race engine in a minivan chassis. Powering the setup is my current GPU, the RTX 4060. Now, don't get me wrong, the RTX 40 is efficient, it's cool, and it's compact. But today, we are stepping it up a notch. Stay tuned to the end of the video to see what parts we've chose, see our benchmarks of the before and after, and everything else. But before we upgrade, let's talk numbers. I ran Firmark, the GPU stress test that makes graphics cards question their life choices. Before the upgrade, you're seeing that I have gotten 7,140 points in Firmark, a max GPU temperature of 72 degrees Celsius, and a max GPU usage of 97%. So thermals, absolutely solid. I mean, look at this case. We have 3 big fans in the top that are more than 60 millimeter fans. We have a Noctua NH CPU cooler, and we have this 4060 with, ironically, has a fan underneath it as well. So there's no surprise that we're getting good cooling as it is. And unlike the RTX 5070's younger brother, the RTX 4060, 5070 boasts a next generation architecture, higher CUDA core counts, faster memory bandwidth, and the kind of raster and ray tracing performance that makes 1440p feel like 1080p used to. Now, it's important to note, I only have a 1080p monitor, but I did overclock it to 310 Hertz. So we should be able to see the max performance that we can bump out of this system. But that's not all. We are pairing it with the Ryzen 9 9900X3D. Unlike its X3D counterparts, this chip boasts AMD's stacked 3D V-cache technology, dramatically increasing its L3 cache and delivering ridiculous gaming performance thanks to minimized latency and maximized data throughput. It is currently the best CPU on the market for both gaming, work, and anything alike. But, as you guessed it, we have more things to this upgrade. Now, obviously, these more parts are obviously the rest of the PC, including the power supply, and, of course, the motherboard that we have now, and our GPU. We have to swap out everything that we have right now and put this all in my same case that I'm currently using. And you're probably wondering what the power supply is. Well, our new power supply is the RM1000X series by Corsair. Let's open the box. So first thing on the box, you can see this is a fully modular power supply. And what this means is that you can freely connect any cable to the very back of the power supply instead of having to mangle with a bunch of connectors. It uses new ATX 3.1 up to PCIe, which peripheral connector interface 5.1 with up to 12 volt 2x6 power. It is made for the RTX 50 series, as says on the box. It is a platinum rated power supply and is designed to last years to come. Alright, so enough talking, let's get the power supply opened up first. So, as you guys can see, right away we are greeted with a bunch of cables, a scary amount, but we got basically around 15 different cables here to use for the power supply. Great job, Corsair. That should get us through what we got to do today. We got our standard power connector. Very good, nice packaging, must say. Even smells pretty good as well. I know some people really like that with electronics. Let's take the power supply out of the box and let's take a look. So, this is fully modular. Look at the very nice grill on front of this, very premium. We got all of our power connectors back here. I think we have about 14 on the back here. We have a fan control knob on the back here, which will be useful to some people, but not everybody, especially if you have a fan controller or you don't want to have to reach back behind your case very often. Most people don't have very long arms, so this is a very big inconvenience. But props to you, Corsair, for including it anyway. This is the moment where the build officially stops being a recycled build. Because today we are installing the new Asus B850 Max gaming Wi-Fi motherboard. Enough talking, let's get this thing cracked open. So, first of all, we gotta just quickly get the seal. I'm gonna be using my trusty little power bank, my trusty little power brick, to get the seal. Here. There we go. The seal is now broken on this, and we can open it up. So let's do this. First of all, very clean, nice, organized packaging that Asus has done. Let's see the included gear before we get into what the motherboard looks like. Wow, seeing this up close, it looks very premium. Doesn't smell as good as what the power supply did when it came out of the box, though. We have our Wi-Fi antenna. Of course, this only matters if you're really going to be using wireless internet. Most people today use wired internet or Ethernet on their device, since it is more fast, stable, and easy to use, and reliable for better speeds. But we won't be talking about that in this video. We will be building the computer. So, let's talk about the core specs. So this boasts a AM5 socket for the CPU. It has a AMD B850 chipset, hence the name B850 Max. It has 8+2+1 phase digital power design for stable CPU delivery, 4 DDR5 DIMM slots supporting up to 256 gigabytes and speeds over 8,000 megatransfers per second. The PCIe 5.0 has a 16 slot for next-gen GPUs, 2 M.2 slots here, covered by these nice screw brackets, which most OEM boards do not have. Sorry that my camera keeps falling down. But let's take a closer look at the VRM heatsinks. So, we can see that this is a very, very clean board. As you can see, great job, Acer. Once again, you guys have the screws protecting the SSD, the standard protector on the CPU. Obviously, the 24-pin power connector, which wasn't on my previous board, and up to 5.1 PCIe. We are going to be installing this board very shortly. And unlike this board's younger brother, which only supports 4.1 PCIe, like I said, this also supports 5.1 PCIe. I'm just going to be quickly trying to get the rest of the things out of the box here. It's a really, really weird box design, and we got to try to get everything out nice. Okay, this box design makes perfectly sense now. Good job, H3. Got this new cable here. This is for the hard drives to be plugged in if you're going to be using standard SSDs. Of course, this doesn't matter if you're going to be using M.2 drives, since it just screw into the slot on your board. This is the big moment. We are unboxing the new 5070 as promised. Oh my gosh. It's Asus Prime. It's PCIe 5.1, and it has, let's see, 12 gigabytes of memory, which RAM, by the way. Memory and storage are two different things. If you don't know that, search it up on your own and find it yourself. But anyways, let's open this thing up. So, we gotta open up the back. And unlike its generational old brother, the RTX 4060 in the system right here, this is the 5070. This card, the 5070, boasts next-gen architecture on the Blackwell chip. It has higher core counts, faster memory bandwidth, and the kind of raster performance that makes 1440p feel casual and 1080p feel like a joke. Enough talk, let's open up this very premium looking box right now. So as you can see, Asus did a great job on this. As soon as we open it, we see that we have the instruction manual, very nice, directly in the front, so there's no misplacing it. We have the 5070 itself, which looks really nice, has 3 fans. Unlike my 4060 that has 1 fan. And this is a chunky boy. So we got something to help it out because of this. We got an anti-sag bracket to help prop this GPU up, make sure it seats nicely, and make sure that its 5-pound heavy weight doesn't collapse on the weight of my PCIe bracket. This should help it have better performance, lower temperatures, and less overhead. In our next steps, we are going to be taking this computer off of the desk, disassembling it, getting the new parts installed, and getting everything else working properly. So let's get started. Now, what we gotta do is, you see how this side panel is like that? We are going to need to screw off this side panel before we accidentally trip up on it or it gets in our way of what we're doing. So we just take this little screw out here, and then we're good to go. I'll double time that part of the video. All right. Now, I got to take out the side panel. Just like that, we slid the side panel out. Some side panels, you guys might have to unscrew the sides and take it out manually, but with my case, it's a pretty good case, so it has some built-in features to help you. The side panel off, it is time to move on to taking everything out of this computer and putting in the new stuff. So, first of all, I'd say that a good step to do would be to take out our hard drives. Then we will work on to getting the CPU out, the GPU out, and the fans and the rest of the equipment. So let's do this. Hard drive number 1. This is my WD Black 2 terabyte. You guys should definitely pick up a WD Black. They're very good, very nice speeds too. I'm just gonna lay this to the side over here, and now we'll take out the next one. It'll be a little bit hard to take out because it's in between my GPU. Yeah, we're gonna have to take out the CPU cooler first in order to be able to get that hard drive out. It's time to unplug the graphics card and for us to take out the cables. I'm speaking loud because I have people over at my house and I want this space to be as quiet as it possibly can be. I think I put my... Okay, I found the bit. Okay, we're good. I thought I lost it for a minute. Okay. I thought I lost it and thought I lost it. So, here we are. Next up, we have this little screw that we gotta undo. You can use this as a thumb screw or you can screw with a screwdriver. I'm using the LTT screwdriver because it is the best screwdriver for this type of job and it is widely used by a group of content creators. More people than just Linux. Even people who do car repairs use this screwdriver. But enough glaze talk and enough screwdriver talk. Let's get this out. So, as soon as you get the 2 screws out, you gotta wobble it out, just like that. It should come out. If you feel any pressure, then you are doing it wrong. This is my old card, and we are going just to lay this to the side. Next up, what we're going to do is take off my CPU cooler. So, we are going to go on the side here. I should be able to see where this fits on. I might have to review my documentation for my CPU cooler. So we won't do the CPU cooler right yet. We will take out the two power connectors going over to the power supply that we currently have in because we're taking that out, of course. So we're going to unplug these 2 connectors. Boom, the 2 connectors are unplugged. We are going to unplug this last connector, and now the power supply should be completely unhooked. We're gonna have to be careful, guys, of these connectors up here. These are the front panel connectors. They make it so that your computer can power on. If you don't have these plugged in the exact direction that your manufacturer and motherboard says, then it will not be in enough. And these are very tiny pins, so you have to be very fragile with them. Here we have the motherboard. We unhooked everything, so you guys know what's next. We have to unscrew everything on this board. We have to take it out. We have to pop that CPU out, pop the RAM out, and pop the hard drive out because we will be using it in the new motherboard. So, enough talk, let's get to it. Update, motherboard's out. We are just unscrewing the PSU, aka power supply, from the board. I'm gonna give you guys one tip and one pointer though. Before you take out your board, I highly suggest that you guys will hold down on the power button after you've unplugged your power supply, because some power will still be held left in the board from where you had it turned on last, and that can prevent short circuiting if you get any shocks when you're touching the board. And shocks can kill your components. So it's important to be safe. Anyways, let's get this out. This out. There we go. Now this power supply should be freed from the back side here. I'm gonna quickly take this out. Boom. It's out the back side now. Should all just come down. Boom. The old power supply is now out. we're going to lay this to the side. New power supply looks a lot better too. Just unboxed a new beast of a CPU. This is gonna be so much better performance. Look how nice this thing is. So we're gonna put the new motherboard in right now so that we can support this socket type and we could put the CPU in. So let's get to it. Now you see this right here. You're gonna have Takes Protect cover off like it says here. It's very important to keep the cover just in case you need servicing, you need to send your motherboard for servicing. The servicing does not cover the little traces being scratched. If you have that done on your motherboard, the last resort option is to actually, believe it or not, put in the oven to be able to heat up these traces and possibly reconnect them. But it's very low chance that you'll revive your board if you do encounter that issue. Without further ado, here's the next step. You're going to push down on this CPU lever. You're going to feel a bit more resistance and pressure than you normally would think, but just commit to it. Pull this up. Take that and push that back. Then you're going to have this. And you got to pull this up. And then you push this plastic piece out. Just like that. Boom. The plastic piece is out. The socket. Be careful with these types of sockets. This is a socket with pins. If either one of these pins get bent from their original position, you will not be able to put your new CPU in and you'll have to manually bend everything back, which is a hard process, a strenuous one, and a process that most people end up completely breaking their board with. So be careful. Time to put the CPU in. So here's how it works. You're going to want to, not touch any pins on the inside, of course. Let's hope I didn't touch any pins. Oh my god, that would have been bad. I could have frigged it up. I hope I didn't, but the gold triangle goes in the left top corner. Yes, it's in, guys. It's in. If you just wiggle it. Do not press down. You will bend the pins. Put this down. Take this lever. You're going to feel a lot of pressure here. Notice when I put it down that I'm going to feel a ton of pressure. But you got to commit to it. You got to do it anyway. There you go. The new CPU is now in. So, our current layout for our board is perfect to be able to put the board in now. Every one of the standoffs are lined up. You got to make sure about this on your board or you could short circuit something. You could break the board and you could waste your money. And you don't want that. These warranties only cover certain breakages. But next up, we are going to be putting this cooler back onto here. And we're going to be cleaning this monstrosity amount of dust from the cooler. So let's do that. Guys, I'm sorry for not filming this part. I had to plug in the front panel connectors. It took me a while to figure it out. But we have the new CPU in. We had the motherboard in. We had the GPU in. All I got to do is put the thermal paste on the CPU. And then we can go ahead and install the CPU cooler. I had to go get more thermal paste. So that's why I took so long to do this part. But yeah, let's just install the CPU cooler now. Hey guys, so I didn't install the CPU cooler on the video because it was causing me a bit of troubles. Had to find out what standoffs I was supposed to use and it took a while. So I cut that out of the video to make it shorter for you guys and make it so that you can enjoy the video further. But without further ado, let's benchmark my new setup with everything put in place. I will mention to you guys that I did have to return that motherboard and get a new one because of a system post error. But I got a new motherboard and everything is working fine now. So I just wanted to let you know. Sometimes when you get a motherboard, it'll be too underpowered for the CPU and it will not be able to launch. That was in my case since the Ryzen 9000 series often had that issue, especially the Ryzen 9 with this architecture. So just keep that in mind. Without further ado, let's just benchmark and see how the performance comparison compares to the 4060 with the i7-13700F. Firmark performance benchmark on 1920 by 1080p with the RTX 5070 and the Ryzen 9 9900X 3D. Let's start the test. You can see we're reaching about 64 degrees on the GPU, up to 94% usage so far. That was 64 degrees in the 1% lows. We have the AMD Radeon graphics, ignore that because that's integrated graphics. We're going by the GPU only right now. This is a GPU test. The VRAM is used up by 13%. Fan is at 56% usage, both fan 0 and fan 1, which that's fan 1 and fan 2. So far, 3.85 milliseconds, and we have the furry object rendering turned on. So far, it's taken 60,000 milliseconds to complete, and we have rendered 16,000 frames total. Our total benchmark with the RTX 5070 and the Ryzen 9 9900X3D is 16,407 points with the average of 273 FPS, sorry. And we're running OpenGL 3.2.0, which is the driver, version 595.79 at 1920 by 1080p. It took 60,000 milliseconds to complete, which is about a few seconds. So yeah, let's compare it to our 4060 and Intel Core i7 13700F now. Probably saying, Ben, what's really the big difference between these two components? Like, is it really that big of a difference? Is it worth my money to splurge out and get a way better CPU, way better GPU, and to spend more money? Well, unsurprisingly, due to my testing, yes, it is a great idea. Not only because the AMD Ryzen 9 9900X3D has a new 3D V-cache, which boasts insanely high performance, but according to our testing, we got more than double what we have gotten in points on firmware compared to our previous configuration. On the Intel Core i7 13700F, you're seeing that we got 7,140 points, but on the Ryzen 9 9900X3D, on the other hand, we managed to break 16,000. Another thing you've noticed is that on the Intel Core i7 13700F and the RTX 4060, we have got an average of 118 FPS, and on the RTX 5070 with the Ryzen 9 9900X3D, we have gotten around 200 FPS average. This is all running in 1080p, not 1440p, and this is a very strenuous benchmark using ray tracing and a whole bunch of things like that. Both tests were ran at the exact same time, and for using the exact, resolution and everything like that. Next thing we noticed that I thought was very important to talk about in this video is the GPU temperatures. So, right over on the RTX 5070, we got about 66 degrees max, that is in Celsius. But I'm pretty surprised, honestly, of the temperature differences. Despite the RTX 5070 being a more high-end card with more cores, better performance, and higher frames, it's able to get allocated. It manages to boast less temperature than what the 4060 has gotten. We can see that the 4060 gets around 70 degrees Celsius in temperature max before it starts to throttle and cool down. Over on the RTX 5070, we're seeing much less, around in the 60s, but this makes sense since the GPU I was originally using only had one fan, and this one has a better heatsink and 3 more fans. So not only was this upgrade better for performance, it was also better for efficiency and for cooling. In conclusion, I would say that I would highly recommend this configuration to most people People think that the 5070 and the Ryzen 9 9900X3D don't go well together, but it's actually one of the most less insignificant bottlenecks that you will get in a system. It's a pretty well-balanced CPU and GPU configuration, and it would do really well in most modern games, if not all. So, thank you for watching this video. Be sure to like, be sure to subscribe, be sure to like the video if you liked it, like the video dislike the video if you disliked it. Share this to a friend if you enjoyed it, because I highly appreciate your shares, and I appreciate them a lot more than your likes as well, and it helps us get the video out there all over YouTube. So thank you guys for watching. I'll see you in the next one.